Okay, hi Kel and Finn. Sorry, but the video we did of Wednesday's lesson sort of got wiped. So we just went through a bit of a summary of things, but then we also looked at specific types of functions that are in our outline. So hopefully we can see this, and I guess I'll pop a copy up on Daymap. We sort of made notes of this in class rather than looking at this, but you know, hopefully we all remember what a one-to-one function is. And we can prove it algebraically. So we go, yeah. We were happy with an inverse function.
Do you understand that, right?
So how to find an inverse function? It reflects in the
horizontal would be
y equals x-axis, axis line. And basically it means that you swap your x and your y values around. And of course it has to pass the horizontal and vertical line test for it to happen. So if you were given a graph, you could just, you know, reflect it and pick the points that you have and whatever. So we were able to graph f to the minus 1 just from looking at the graph itself and do it algebraically if we needed to. So then we went on and we were looking at absolute value of the whole function, right? Because we'll also look at f of the absolute value of x. Now each one of those has a specific geometry to it. So we said here all negative y values become positive. So basically any part of the graph that's below the x-axis gets reflected up. And we went through and picked a few graphs and we did it in the calculator. So if you would like to do that in your calculator, you can so desire. Actually, we'll show you just a reminder, because some of us did forget how to pop that into our calculator. So sorry, just waiting for it to open, and you're probably going to get yours. What is that? Oh, it's just a cute little flower. There we go. Okay, we're back. So well, I didn't put the equation there, but we can definitely pop one if we want to drop it down. So you could actually see this would be x squared take 6. Because it's just dropped straight down. So we go x squared take 6. That's beautiful. Have we got standard? Yep, nice. And then how do we pop in our modulus? I'm talking to Will here. Does he remember? We're going to go option numeric.
Oh, numeric.
Now you can go absolute value and then retype that x squared take 6, or we can just go the abs of y1.
Oh.
I know. And we did, you can see, we did a fair few of these on the board, but if you think about what that's asking you, is it's turning any negative value into a positive.
Because it can't be negative.
That's right. So it sort of makes sense that all the positive values sort of stay as they are, but any of the negative is reflected in the x-axis. It's just reflected up. So that's one of the things that we then go, okay, let's note that down, and we know that that's a property. Then we went and had a look. I mean, you can do all sorts of ones. So this is a rational one, so it links in with the rational functions that we've been looking at. And again, this part here would stay the same. So draw. So this is actually the same as this, unchanged. But this part here has been reflected in the, right? So anything that's negative below the x-axis gets reflected up. And you can, you'll be doing a few in the worksheet that we have in a moment. So what was the summary for this? It's basically, that was still f of x. So now we look at this one. We could graph this. Right, when we graphed the original one, let's go back to our graph here. So let's go back and we would now go options, numeric, absolute value of x, and then we'd square that and then take 6. Right, so how does this compare? So this is now the green one. And it's exactly the same. Why? Because when we square a negative, right, the actual equation here, when we square a negative, it becomes a positive anyway, and then take 6. So that makes no difference to this one. Yeah. However, if we then change it, so instead of being symmetrical about the y-axis, if we were to change this to be, let's say, x minus 6 squared. Right, so it's now moved to the right. And I guess we could even move it down, can't we?
Yeah.
Or do you want to move it down? We can move it up or down later on. So let's go down by 3. Okay, so now we press exit, and when we do, go back to have a looking at it. Let's do, what would this look like? So again, what did we say that does? Anything that's below, so we'd expect it just goes loopy, that little loopy bit. But what does our other one do? So again, we would go option, we would go numeric, absolute value, x minus 6, and I forgot to put the brackets in. Close my bracket. Square take 3. Okay, let's have a look now what the black looks like. Oh, and you think it's just, reflected there, and in fact it is. We've got its reflection in the y-axis. But what happens when we go all the way up?
Oh, when it hits.
Right, it doesn't. The pink one no longer exists, so it's only the right-hand side. So this is probably a better one. That's why I did that one. Where'd it go? Down here, right? Better one. So you can see the part here that's on the left-hand side of the y-axis is no longer there.
Yeah.
It's only on the right-hand side that's reflected in the y-axis. So again, that would be something that we write down for geometrically how we do it, because the idea is that you'll get a function without an equation. So it's not like you can just type it into your calculator and do it.
Yeah.
You just have to do it on the scale. And then of course we've already looked at reciprocal/rational functions.
Yeah.
So when we then come to look at this, right, it's sort of combining those things, right? So this first one, we go, yes, we're going to do a couple of things. We're going to say, well, we know there's a vertical asymptote. So we would know that this thing should be labelled as x equals -2. We know that there is a horizontal y. What's that one? Right, it's 4/1. So that, so we know that it's, so we remember that from the summary?
I was getting a little confused about the horizontal.
So when it's linear on linear, we divide the coefficients, the leading coefficients.
That's how it works.
Yeah. When it's quad on quad, it's the same thing. So if I've got 5x squared over 3x squared, blah, 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 then we'd have y equals 5/3. When it is small over big, you got that sheet, right?
I'm not sure. I think I might have.
We should have that sheet. So when we go here, the rationals, oops, is this my year 12? How sad. Skills check, worksheet, rational functions, right? So this one here, yes, you were here for this, William, you've forgotten, right?
Oh, yeah.
That summary there. So when we've got small over big, it's always going to be y equals 0.
Oh, okay.
When it's a bigger over a small, that's when we can use division to get the oblique asymptote.
Oh, okay.
So we've got some of those in here as well that will come up. But so you'd have to graph this one. So we're going, that's where you get a highlighter. I've got my highlighter here, and we go, okay, what does this go again? It means that anything on this side stays. Oh, that's a bit thick. Anything on that side stays.
It's cool, you can still raise it.
I know. And anything on the left gets
Inverted?
reflected up. Yeah. So this now becomes, I have to reflect that up. It's a bit hard. So there we go. And it still doesn't cross the asymptote that's there because it's reflected in the x-axis. So try not to look at the solutions.
Yeah.
But, oh, did I stuff that one? F of x. I think I might have stuffed that one. Go back and check. What did I do?
Is that the...
I think I cooked it. Look at that, and it's on video. Oh. Reflected. I was getting confused with reflecting it up. Bad me, bad me. X-nay, X-nay, X-nay.
Is it reflected like that if the whole
So
thing
it's
is
reflected, sorry, we just said it was reflected in the y-axis, wasn't it? Not the x. I went y. I went x. So, oops, we go that way. And keeping in mind that's not good either, because it shouldn't cut my asymptote there. So, yeah. Sorry about that. I was mixing it up.
So if it reflects in the x-axis, is that the full f of x in the modulus?
Yep, so this green, that is that function. That would be, technically, y equals 4 modulus x. Take 1 all over modulus x plus 2.
Ah, right.
Right? And what I was getting confused about, because I did it in a different order before, I should have looked. This one is y equals the modulus of whatever that function was, 4x take 1. And so that makes sense for what we're doing, is anything that's positive stays where it is, but anything that's negative becomes, positive.
Yeah.
Yeah? I thought I was being clever by including the reciprocal, but that got a little bit carried away. So basically that point would be now, so 1 divided by 0, so you got undefined there, you've got an asymptote. 1, 1, that would stay where it is, and then everything else, like this is 1, it didn't work as I wanted to, and that, have a look in your calculator for that one if you wanted to, but it sort of just wasn't what I was expecting. Anyway, so the other ones are pretty good. There are some missing bits and pieces. So now if we look at this, we go, ooh, haven't got these, but you should be able to get it from the asymptote. So this is -1, -2, -3. So that means x plus 3.
Oh, yeah.
Right? And then that one would have to be x take 1.
Yeah.
So now we have the function if we really wanted to. Can we graph? Make that smaller. Can we graph this one? So again, anything, what do we say for this one? Anything.
Anything that cuts the y-axis.
Yep, anything that's to the right of, isn't it? Is good.
Yep.
And here, but we're going to reflect that in the
y-axis.
So that becomes like so. And then this one is also going to be reflected. So what's my asymptote here? It was -1. So, sorry, it was 1.
Yeah.
So now it's going to be, and that sort of has to go down there. So I think, let's have a look. Yeah. Oh. Stuff that one. And it reflects. I've got to listen to what it's saying. Go back. No. I'm just trying to go too quick. So what do we say here? All negative y values become positive. Right? So all negative. Oh no, I'm doing the first one. Oh, see, I've got that in my head. So sorry, Finn and Kelly.
I think so.
Remove any part of the graph that is to the left of the y-axis and reflect the graph that is to the right of the y-axis. Oh, I think I'm okay, but I'm doing them in different orders. So remove anything to the left. Yep, we're happy with that. And so that will go like so. So I don't know what's going on with this one. Did I graph the wrong one? Oh, I looked at the wrong one. Should have trusted myself. So I was looking at I didn't scroll all the way up. So does that make sense? So this is now no longer, it's irrelevant because it wasn't on the right side off. So I think we need to make sure, yes, we're understanding what that means, but then we're also looking at the geometric stuff. So that's something that we should write down.
Yeah.
Okay? And that was probably about it. We looked a little bit more at the modulus, but we're going to save a little bit of the alg for Tuesday morning. Oh, we might even do it later today.
Yeah.
Okay?
Yep.
Does that help?